Everyone, there are a couple of challenges that are faced by airlines, such as delays, technical problems, unhappy customers, staffing shortages, and more. My project is about improving how airlines and the major entities related to them operate at a technical level. By technical level, it means how data is generated and processed across these entities. Let us talk about the data. Since we are talking about airlines and the different related entities, the data is generated in large amounts. The data is generated by airlines, it is generated by airports, and it is generated by air traffic control. Now let us talk about data that is generated by airlines. It includes customer satisfaction data, booking related data, flight information, aircraft maintenance report, and so on. Now let us talk about data generated by airports. Again, it includes booking related data, flights information, passenger screening information, passenger details, and finally the data generated by the third main entity, which is air traffic control, includes flight information linked with radar generated data such as altitude, speed, and transponder information. Now let us talk about the proposed solution. Here is the overview of the proposed solution. Starting from the top, MapReduce will be applied to high volume data generated by traditional relational systems that are operating within the scope of each entity. Here the entities are airports, airlines, and air traffic control. The data output of MapReduce will then be stored in wide column stores, and then creation of nodes and relationships will be done. Let us now talk about the effectiveness of the proposed solution. How effective is it going to be? Let us first see what the proposed solution looks like. High volume generated data will be passed on and MapReduce will be applied to it, and it will be stored in wide column stores, and then nodes and relationships will be created using NoSQL graphs. Since we are dealing with the volume problem, the main thing that should be considered at all times is availability from CAP theorem, as data should be available at all times. MapReduce will be the biggest step in handling high volume data in this case. The proposed solution will ensure availability and efficient handling and storage of data. MongoDB, which is a document database, I thought it could be an alternate approach, but there is a reason why it is an alternative approach and did not end up as a main approach. In fact, there are a couple of reasons. First reason is that MongoDB can be memory intensive, which means it can exceed the usage of RAM, thus affecting the performance, especially when working with large datasets. Another downside of using MongoDB is query performance. Certain queries may not be able to perform well if we use multiple join conditions and a lot of aggregate functions. Even though MongoDB uses a flexible schema, there is a downside to it, as each document contains field names along with the actual data, which can quickly increase the storage size. So it is ultimately going to increase the cost, and the cost of the hardware is going to increase. So it is not going to be an ideal approach. Now let us look at the complete proposed implementation. The figure that you are seeing on the right side is the high level schematic of the entire implementation. High volume data will be generated by traditional relational databases that are being operated within the scope of the entities, and here in this case, the entities are airports, airlines, and air traffic controls. In order to handle huge volumes of data, we'll be using MapReduce, and MapReduce will be implemented on the data. And then the output from MapReduce will be stored in wide column stores, and we will create nodes and determine their relationships using NoSQL graphs. Thank you.